Welcome back! More than being just the math calculator section minus a calculator, pun intended, the Math No calculator stresses different concepts and requires alternate strategies. Here we'll be looking at some problems in order to guide you through some important strategies for success on this section.
If you find you continue to struggle with these problems after the lesson, or if you just want some extra help, consider upgrading to Testive coaching.
Well, let's get started.
The first math non-calculator problem that we're going to look at for today is really going to test your knowledge of how to use FOIL. That is, how to multiply two terms of the form x plus or minus some constant multiplied by each other in order to get a quadratic of the form ax squared plus bx plus c. So FOIL here will stand for first, then outer, then inner, and then last. That is, the first thing we're going to do, if we just take these two factors here of that quadratic and just multiply the first terms by each other, we're going to get x squared. Then we want to go on and multiply the outer terms together, so the x and the negative 5, or x squared minus 5x. Then the inner terms, 4 times x, so plus 4x. And then the outer terms again, 4 times negative 5, yielding negative 20. So once we've already done this, and we can actually simplify this part here in the middle, where we would get x squared minus x, since negative 5x plus 4x gives you negative 1 times x, or just negative x. And once we've done this and applied FOIL to this part of the equation, we can finally multiply this entire thing by 2x. So remember, we were ignoring it for a little bit, but now we can just distribute this across from left to right within the parentheses, so that we get 2x times x squared, or 2x cubed, 2x times negative x, or negative 2x squared, and 2x times negative 20, or negative 40x. And now we could just try to match this with our answer choices. So this one says 2x squared instead of 2x cubed at the beginning, so we can get rid of that one. This one here, for the second term, says positive 2x squared, it's negative. And this one here, for the last term, says positive 40x, should also be negative, so B is the correct answer choice. This next non-calculator question can be fairly quickly to solve if you remember a couple things. There's going to be 3 different geometry formulas that you need to remember here, or rules, that are going to apply to triangles and what we call supplementary angles across lines. So the inside angles of every triangle have to add up to 180 degrees. So to figure out this unknown, we can just subtract 58 and 37 from 180. I'm going to go ahead and label 58A, 37B, and this unknown I'm going to label, let's say, F. So the inside angles of a triangle, then, when you add them up together, have to equal 180 degrees, which means that if you were to solve for this missing value, you could find the value of x and then the value of y and then the value of z independently. Add those up together. This is because supplementary angles, so whenever you have a straight line and some transversal, these two angles on either side of the transversal, I'm going to call these, let's say, H and I. When you add those together, those are also going to equal 180 degrees because they're going to be supplementary. Okay, well, the third thing you need to remember, and don't forget this, you don't actually need to do all of that work to figure out the answer to this question. You need to remember that the exterior angles of a triangle always add up to 360. And we can go ahead and solve for this triangle why that is using these first two formulas just to prove it to you. But whenever you add out those outer angles, in this case zx and y, they always have to equal 360 degrees. Let's go ahead and prove it just for the sake of proving it for this problem though. So if we want to figure out this missing value here that I've called f, we can say, well, a plus b plus f equals 180, and then substitute 58 plus 37 plus f equals 180. And then adding these two together, that's going to be 95 degrees plus f equals 180. And then we can subtract 95 from both sides, and that's going to give you, whoops, I'm just going to go ahead and do this really quickly. That's going to give you 85 degrees, right? So that gives you 8, 7, yep, that should be 85 degrees. So then we know that f equals 85 degrees. Well, to find x then, since f and x are supplementary, think about it this way here. We got f on one side and x on the other. So f plus x then have to equal 180. We can just plug in what we know for f. So if f is 85 degrees, and that plus x has to give you 180 degrees, we can subtract 85 from both sides, and that should give you, I'm just going to do this over here. That should give you 95 degrees for x. So then we know that x equals 95 degrees. We're adding this to y and z. So for y, we have that b equals 37, and we want to find the value of y. So 37 plus y equals 180 degrees. Subtract 37 from both sides, and that's going to give you, that's 180 minus 37. Yeah, so that should be 4 over here, and then we bring down the 5. So that's going to be 143 degrees. So we can say 143 for y. And finally for z, 58 plus z has to give you 180. So we can just subtract 58 from both sides this time. And once again here we're going to get a really big number, which is good. That's what we wanted. That should be 122 degrees. So if we add all of this together, that's going to be 95 plus 143 plus 122. Well, let's go ahead and line them up together and add them up that way. That's going to give us 5 plus 3 plus 2, that's 5, so that's 10. Then 10 plus 4, 14, plus 2, 16. And then 1 plus 2 plus 1 plus 1, that's just 3, so that's 360 degrees. But see how much work that took? You don't need to do any of this when they ask you a question like this. All they're testing for is whether or not you know that the exterior angles of a triangle add up to 360 degrees. So you could do it this way, but strongly advise against it. It's definitely worth it to memorize this rule.
This is a factoring problem, and factoring can be a little bit scary on standardized tests because there's trial and error involved. But if you go ahead and look for a couple patterns, you might be able to approach these problems a little bit faster with a little more confidence. So the first thing that I notice when I see this polynomial is that the first and last coefficient are related to the middle coefficient. They're half of it. So 4 is half of 8. And also, that the middle coefficients, or the middle exponents, so 3 and 3, are half of the first and last exponents, 6, and that the variables that we have, that they also follow a pattern, so that we have, m and n at the ends, and then we have m and n in the middle. So this is actually a familiar polynomial if you know what you're looking for. Believe it or not, this polynomial is just like x squared plus 2xy plus y squared. Okay, now they may not look all that familiar right off the bat, but let's add a couple things in and make them look a little more similar. So this is really the same as 1x squared plus 2xy plus 1y squared, and it's really the same as 1x squared plus 2x to the first, y to the first, plus 1y squared. So now we actually have all the pieces that match. We have coefficients at the beginning and the end. We have variables that match from the beginning and the end to the ones in the middle. The coefficients are half of the middle one, and we have exponents that are half in the middle of the ones on the outside. So why does this matter? Well, this polynomial is actually a pretty straightforward one because it factors out to be x plus y times x plus y, which is just x plus y squared. Okay, so that could be pretty helpful, right? And if you FOIL that out, you get x squared plus 2xy plus y squared. So that could be pretty helpful because really, if you think about this, it's not just x plus y squared, it's like 1x to the first plus 1y to the first squared. So that is kind of familiar, that is kind of helpful as we compare it to another polynomial that looks similar but with some different coefficients. So the thing to remember about these exponents is that these coefficients, just because like 4 is not actually any different sort of a number than 1 in this case. 8 is not actually different sort of a number than 2. All that really matters is that they have the same relationship with one another. So what we should be able to do here is recognize that what we're going to pull out is the square root of the first and last term. Okay, so 1 in this case was the square root of 1. All right, so we're going to pull the square root out. So the square root of the first term is going to be 2. The square root of the whole first term, so that's actually going to be 2m to the third. Now you might be thinking m to the third, that's the square root of m to the sixth. It is because remember that, I'm just going to put a little box up here. Remember that variables with exponents, when you multiply them by themselves, the exponents add. Okay, so m to the third is the square root there. So we have 2m to the third plus, well, let's match it up. Then we would have 1y to the first, so that would be 2n to the third squared. And that is one of our answer choices. Now, you might be thinking, well, am I supposed to remember all of that when I'm solving this problem? Not necessarily. So let's see if we could actually take a look at solving this problem a different way. Okay, so what if you were to solve this problem by just starting with a little bit of trial and error? So you were to say, okay, well, I have a 4 here. What if I just pull my 4 out first? And I take 4 times m to the sixth plus 2m to the third, n to the third, plus n to the sixth. Okay, well now you actually can see that this polynomial outside of the 4 matches even more closely with the one we were just looking at. So then you would know that this is 4 times m to the third plus n to the third squared. Okay, well, you might get to that point and think there's nothing else you can do and feel like you did the problem wrong, right? Because you don't have any answer choices over here that match. When you're doing a factoring problem or an equivalent expressions type of problem, you shouldn't lose faith in yourself in having done the math correctly. You just need to apply yourself to manipulate the numbers to match one of the answer choices available. So in this case, we can actually see that we would be able to distribute the 4 through because 4 is a square number. So we can actually distribute that 4 inside to make it 2m to the third plus 2n to the third squared, right? Because you can just take that 4 and put it inside, because then these would both square. If you took them back out of the expression and square them, they would equal 4. So that would be another probably quicker way, although you still need to know about the x squared plus 2xy plus y squared way to solve this problem. Let's start by reading the problem here, and then we'll make sense of the graph after we understand what the problem is asking us to do, or as we determine what the problem is asking us to do. A middle school teacher created the scatter plot below to determine the quantity of pencils she purchased throughout the year. I guess that should say the year, excuse me. How many pencils can a teacher buy with a budget of $5 if the cost per pencil is the same as the cost per pencil when 35 pencils are purchased? Okay, so the first way that you might get tripped up here is if you were looking at this scatter plot, and you're going to see a lot of scatter plots potentially on the SAT, maybe not on every single one, but as you take it over time. The first way you might be tripped up here is you see, okay, 35 pencils. So you see the amount of pencils is along the bottom here. And so 35 is going to be right in between 30 and 40. And then you can see that money spent is going up here. And it looks like the amount of money spent on 35 pencils is $3. So you might get tripped up and think, well, if it's $3 a pencil at 35 pencils, then you could only buy one pencil with $5. But this is not money spent per pencil. This is money spent total. Now, you probably knew that, but that's the first place where you might get a little confused about this. You want to keep track of your units here. So this is money spent total. So basically, this is asking... this is showing that a teacher spent $3 to buy 35 pencils. All right, so I'm just going to kind of make a note for myself here. I'm going to say $3, 35 pencils. And we're trying to figure out how much could that teacher buy with $5. So $5 is some amount of pencils. So as soon as you have four quantities where you have two of them are known, like where it's the same units, two of them are known, or three of them are known and one is unknown, that pretty much shows you you're going to be using a ratio. So we're going to set up a ratio here. So we would have $3 over 35 pencils equals $5 over X pencils. Okay, so then whenever we have a ratio like this, we're going to cross multiply. So we're going to have 3X equals 35 times 5. And that would be 3X equals, let's see, 30 times 5 is 150. 5 times 5 is 25, so 175. Okay, so now we're at the point where this is a math no calculator question, but it would obviously be a lot easier to solve with a calculator. Well, you don't have that option. So what do you need to do? You need to be able to kind of estimate you're not going to necessarily set up, you're not going to set up something like 3 into 175 like this. You don't need to, because you only have one of these that's a decimal, and we know that a teacher's probably not going to be buying half of a pencil, so we can probably kind of rule that answer out to begin with. So we're going to be looking for a whole pencil amount. So this is a point where having the skill of kind of estimating division is going to be very helpful. So let's think about how many times 3 goes into 175. Well, I'm going to start by knowing that 3 goes into, let's take 150. 3 goes into 150 50 times, right? So we know it's going to be, I'm going to use this area over here to write. We know it's going to be 50 plus something, all right? So then we look, how many times does 3 go into 25? Well, 3 goes into 24 8 times, and 3 goes into 27 9 times. Well, we're only looking for 25, so we can't go over that. So we're not going to have 8 point something, so it's going to be 8, because 3 goes into 150 50 times and into 25 8 whole times. So we're looking at 58. So 58 is going to be the nearest amount of whole pencils that can be purchased.
So this problem can seem intimidating. Let's first look what we're trying to find. We are trying to find one possible value for C. We are given this equation and told that a plus b equals 6. The first thing that we want to do here is factor out the left side of this equation. So when we multiply ax and bx, we're going to get abx squared. When we take 5 in ax, we're going to get 5ax. 3 in bx, we're going to get 3bx. And for our constant, we're going to get 15. And that is going to be equal to what's on the right. I won't bother writing that again. Once we reach this point, we want to try to create a system of equations where we can find what a and b are equal to. Of course, we have this equation a plus b equals 6. So now we want to use this first equation right here to write another equation that links a and b together in such a way that we can solve for a and b by pairing it with a plus b equals 6. So we need to use information that we know about expanding and factoring equations. If we look, we see that this AB equals 8 on the right, because you see that this AB is in the same position as this 8 in front of the x squared. Since we know that AB equals 8, we can create this equation. Just A times B equals 8. Very straightforward once you realize that the terms on the left pair with the terms on the right. Similarly, these 5A plus 3B is going to equal this C, and the constant is the same. So now we're going to use substitution to solve for this second equation. So a plus b equals 6. B is going to equal 6 minus a. Let us then plug in the second equation. So a times 6 minus a equals 8. Six a minus a squared equals 8. We're then going to set this all equal to 0 and solve. A squared minus 6a equals, plus 8 equals 0. So we're going to factor this into a minus 2 and a minus 4. Now we can go ahead and plug these values in to this equation right here to get b. So let's say a equals 2. Well, in this case, we needed to add up to 6 based on the first equation. So b equals 4. And then we want to see what our value would be for c. We already said that c is going to be this term plus this term. It's going to be the sum of the coefficients of your middle term. And so 5a plus 3b equals c. When we plug in, we are going to get 10 plus 12 equals c, or c equals 22. Now that ends up being this answer choice right here, which will be our final answer. You may be tempted to jump in and begin solving for each of these equations and then attempting to divide them by 3x plus 1. But instead of doing that, let's take a closer look at f of x and g of x first. Now, if we attempt to factor f of x, we'll notice that we get, if we take out a 3x, we get x squared plus 2x plus 1. And this right here is equal to g of x. So what we can say is 3x times g of x, of course, being x squared plus 2x plus 1, will give us f of x. Now, using this rule, or rather, using this equivalence, let's look at a few of the answer choices. I'm just going to go down the list and see what happens when, instead of plugging in for f of x, I keep everything in terms of g of x. So I'm going to look at h of x first and say that h of x equals f of x. I'm going to plug in 3x times g of x for f of x there, plus g of x. At this point, I'm going to factor out a g of x. And now watch what this reveals right here. 3 of x plus 1. And since we can factor out a 3x plus 1 like that, we know that this polynomial must be divisible by 3x plus 1. So we're going to go ahead and choose h of x as our answer. We can continue on and look at each of these, but there's really no point since we know that this h of x is going to be divisible by 3x plus 1. And as I said, if you try to substitute in these equations for each of the functions, and then subtract them or add them and multiply them, you're only going to be wasting your time. So again, this problem demonstrates that manipulation of equations, variables, terms is really the key to doing well on the new SAT. So always be looking for things that look like other things, as we have right here, and seeing how you can use these equivalencies and manipulations in order to arrive at what you're trying to arrive at.
All right. As we've seen, this section can be quite a bit more abstract than the math calculator, which can make it tricky, not just because you don't have a calculator with you. We've tried to stress some key skills such as using advanced algebraic and geometric techniques to manipulate given information to your advantage.
Happy
Happy prepping!